I am Sandhavini Karunaratna, and today in my video I am going to present uh, my summary of my first assignment I have done for wireless network technology module. My registration number is MS 209237174. I am a student of MSc Information Technology conducted by SLIT. Now let's move to the content. In my video, I'm going to explain assignment 1.1, 1.2 and 1.3. In my assignment, I have wrote answers for communication, network communication related questions such as uh, related to protocols, standards, standard bodies, um, layered architectures, and also about error detection and error correction, and how the data is transferred via signals. I have wrote answers for questions like that. So in my video, I'm going to explain all the answers, all the summary of my assignment. First, I'll explain to you about computer networks. Computer networks are created to facilitate the communication requirements or data transfer requirements. There are a set of rules set by two or more parties when communicating through a computer network. These are called protocols. Uh, in communication process, protocols decide what to communicate and when the communication is conducted, or when the data is transferred and going to be transferred, and how the data will be transferred in the network. These are decided by the protocols. In communication process, uh, when uh, when many parties accept a protocol, it is formalized as a standard. Technology standards give a framework which enables communication through devices which are produced by different manufacturers. Standard based interoperability gives the ability to understand and compare products of different manufacturers. Since the standards are accepted globally, the digital communication market is expanded all over the world. Due to the availability of standards, there is no need to implement frameworks from scratch and troubleshoot in network communication. The standards can be divided into two categories are de facto and de jure. Uh, De facto standards are standards which are not legitimated but used by many. De jure standards are officially legitimated standards. Okay, let's move to the next slide. Uh, Standard bodies which are very useful for wireless communication. IEEE Standards Association, International Organization for Standardization, International Telecommunications Union, and American National Standards Institute are some of the standard bodies which are very much useful for wireless communication. Those provide standards to establish secure and reliable wireless communication. Among them, International Organization for Standardization provides recommendations for data communication interfaces, while ANSI coordinates the development of voluntary national standards and to interact with ISO to develop national standards that comply with ISO's international recommendations. ETSI and IEEE are standards which are used commonly in wireless communication. Okay, now let's move to the next slide. Here in this slide, I'm going to explain the relationship between IEEE and ETSI. Both ETSI and IEEE are operating in a 5 GHz band. Therefore, those are collaborating to harmonize brand and 802.11a standards. Now let's see IEEE standards related to wireless communication. 802.11a, 802.11b, 802.11g, and 802.11n are IEEE standards related to wireless communication. Among them, 802.11a is the latest standard which has been introduced. Mm, okay, let's move to the next slide. Here in network communication, we can mainly we can identify two layered architectures. Those are OSI model and uh, TCP IP model. Here I'm going to explain about OSI model. OSI model has 7 layers and it has been created by ISO. The 7 layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. These layers perform different functions. Physical layer transmits a raw bit stream over physical medium. Data link layer defines the format of data on the network. Network layer decides which physical path the data will take. Transport layer transmits data using TCP and UDP. Session layer maintains connections and also it is responsible for controlling ports and sessions. Presentation layer ensures that the data is in a usable format and it is where data encryption occurs. Application layer is where applications can be accessed in the network services. Okay, now let's move to the next slide. Here I'm going to explain about TCP IP model. In this layer has four. This model has 4 layers. The 4 layers are network interface layer, internet layer, transport layer, and application layer. Network interface layer is responsible for transmission for the between two devices on the same network. Transmission between two devices on the same network. uh, Internet layer is used to move packets from source to destination and to provide internet working. Transport layer is used to provide reliable process to process message delivery and error delivery. Application layer is responsible for allowing access to network resources. Now let's move to the next slide. Here I'm going to find contrast and compare and find relationship between ISO OSI 7 layers and TCP IP protocol suite. Both layers are both models are layered architectures. Physical layer and data link layer of the OSI model are similar to the link layer of TCP IP model. The network layers and the transport layers are same in both models. The session layer, the presentation layer, and the application layer of the OSI model are similar to the application layer of TCP IP model. In these models, the protocols are assigned to layers. Both models transmit data as data packets. Okay, let's move to the next slide. Here, the data or information can be transformed as signals in two main ways, or there are main two types of signals. Those are analog signals and digital signals. Here on my screen, you on my video on your screen now you can see a image of an analog signal. Analog signals varies with the time and it carries information such as voice. Okay, now let's see what are digital signals. Digital signals has only two levels which are named as 0 and 1, as you can see in the image. An example for digital signal is pulse rate. Okay, now let's move to the next slide. A signal has attributes such as frequency, number of frequency, amplitude, and phase. First, let's see what is amplitude of a amplitude. Mm, Amplitude is maximum extent or height of a wave. Now let's see what is frequency of a signal. Frequency is number of occurrences during a period. Here you can see two analog signals, and first one is a signal which has high frequency radio waves, and the second uh, is shows how a signal behave when it has low frequency. Uh, when it comes to high frequency waves or high frequency signals, they have higher number of uh, signal cycles or frequencies, while low frequency waves have a low number of cycles per period of time. Now let's see pace of a signal. Uh, Pace is two or more waveforms which are not aligned together. You can see example in this image. Now let's move to the next slide. Bandwidth. Bandwidth is the maximum amount of data pass across a path. This is calculated by subtracting the upper frequency from the lower frequency, or highest frequency by subtracting highest frequency from the lowest frequency. Okay, let's move to the next slide. Here I have you can see how to find out the maximum allowable bitrate of a lossless transmission media and a lossy transmission media. The Here you can see that noiseless channel find the maximum allowable bitrate by uh, multiplying 2 by bandwidth by 10 g to 10 log, and noisy channel you can see in next line. You can see how the noisy channel find out the maximum allowable bitrate. Okay, here's an example. A transmission media has a SN of 1023 and bandwidth of 1 megahertz. Can you transmit a 10 megabytes per second signal through this transmission media? Okay, let's calculate and find whether uh, we can transmit or cannot transmit this. The Here you can see the format, capacity, and when the values are assigned, we get the answer of 10 megabytes per second. So it shows that this can be this media can uh, transmit 10 a signal with 10 megabytes per second signal through this transmission media. Okay, now let's move to the next slide. The impairments of a transmission media. Mainly there are three impairments. Those are noise, distortion, and attenuation. First, let's see what is noise. If an unwanted signal inserts between reception and the transmission, noise impairment occurs. These are there are four types of noise impairments, as thermal noise, uh, intermodulation noise, cross noise, and impulse noise. Now uh, let's see what is distortion. Distortion is signal changes its form or shape. You can see at this two signals in my image in your screen. The first one is how the signal shows at the center, and the next image shows what has happened to how the shape has been changed at the receiver. This is called changing the shape of a signal is called distortion. Okay, the next one is attenuation. uh, Attenuation is loss of energy. In this image, you can see how the energy has been lost uh, during the period of time. Okay, now let's see what is latency of a signal. Latency is of a signal is the time taken to transfer a data through a network to its destination. As you can see in image, it takes some time when we give a input at the receiver at the source. It takes some times to output output from the receiver. So uh, it takes some time. That time duration is called latency. Okay, now let's move to pulse code modulation or PCM. Here you can uh, see how PCM how it is worked in PCM encoder. PCM is one of the processors used to convert analog signal to digital signal. This process is used in telephones. This process consists of three stages as sampling, quantizing, and encoding. You can see that in this image. Now let's move to the next slide. Uh, Low rate encoding methods. I have here I'm going to discuss about two low rate encoding methods, which are 4B 5B encoding, 8B 60 encoding. In this image you can see 8B 60 encoding. Okay, I'll explain this further. uh, okay, now let's move to the modulation. uh, Modulation is modifying the characteristics of an electric signal. Quadratic phase shifting king or QPSK is a modulation method. In QPSK, the input signal is divided into two parallel paths. You can see that in an image. This input signal is divided into two parts by in the divider, uh, into path P and path Q. uh, when assigning the bits are the first bit is assigned to path P, and the second bit is assigned to path Q, and again the third bit assigned to path P, and fourth bit into path Q. Likewise, the bits are allocated into two parts in uh, QPSK modulation. Okay, now let's move to the next slide. Multiplexing. Multiplexing is is combining several channels into one without mixing. Multiplexing has many two types, and those are frequency division multiplexing, and which is FDM, and other one is time division multiplexing, TDM. Frequency multiplexing is for analog signal, while TDM is for digital signals. And there's another multiplexing technology, which is OFDM. It is used in television and audio broadcasting, uh, DSL, internet access, and wireless networks. Okay, let's move to the next slide. Satellite access methods. Uh, Here, I'm going to dis- uh, discuss about main three satellite access methods. Those are FDMA, frequency division multiple access, time division multiple access, TDMA, and orthogonal frequency division multiple access, OFDMA. Those are satellite access methods currently using. Now let's move to spread spectrum technologies. Uh, this technology is used to spread narrowband data signal over a wideband signal frequency. Direct sequence spread spectrum and frequency hopping spread spectrum are examples for this. Now let's see MIMO and beam forming. MIMO is the fact that multiple spatially separated uses are created for by the antenna array in the same time and frequency resource, and beamforming is the ability to adapt the radiation pattern of the antenna array to a particular scenario. You can see some examples for how those are worked in these images. Now let's see FDD and TDD. FDD is frequency division duplex. Uh, it uses different frequencies for uplinks and downlinks. As you here in image, it shows that it uses two frequencies, and in TDD or time division duplex, it uses different time slots for uplinks and downlinks, but both operates in the same frequency. Here in this image, you can see that both uplinks and downlinks have the same frequency. Okay, now let's move to the day. Let's see what is data word and what is code word. Uh, Data word is exact data sent to the destination, and code word formed by adding extra bits to the data word for detecting errors and to correct them. Here you can see data words code. Here by adding 2 bits, the code word has been created. Uh, Here you can see the formula for code word. Code word equals to data word plus extra bit for error checking. Uh, Okay, now let's move to the next slide. Block coding or error detection. The receiver can identify whether the code word has been changed if the receiver has a list of valid code words and the original code word has uh, changed to an invalid one. This process is called error detection using block coding. In this process, the sender creates a code word and sends to the receiver. If the message received by the receiver is similar to the valid code word created at the sender, it is considered as a correct message, and if not, it is considered as a changed code word. In the process of error correction using code blocking, it is needed to guess what is the code word sent by the sender. Uh, when considering with the previous one, error detection, the error correction is much more difficult. Okay, now let's move to the next slide. Cyclic code and checksum. Here, cyclic redundancy check and checksum are used to detect errors in transmission and storing data. Cyclic code is a linear code which has an extra property. If a code word is cyclically left shift, it results another code word. Here you can see a code word. If it is uh, left left cyclically left shift using the given key, it gives this code word. So we can see that it results two different code words. Okay, now let's move to the next slide. Use of transmit buffer and receive buffer. uh, Buffers can be used to prevent data packet drops. Transmit buffer keeps the output rate of the encoder. If buffer feels transfer than the recommended buffer rate, it sends a message back to the transfer coder to slower the process. And if the process is much slower than expected, it can send a message to faster the process. And the use of receiver buffer. Uh, if there's no thread at the time of receiving data packets, the receive buffer stored them according to the priority order. Okay, now let's move to the next slide. Uh, Here, importance of flow control. The previously explained process is called flow control. As I explained earlier, this controls the transmission speed of data by managing the rate of data transmission between two nodes to prevent fast sender from overwhelming a slower receiver. Okay, let's move to the next slide. Uh, HDLC or high level data link control. Uh, this is implemented by ISO. Uh, this is used in data link layer. This protocol is bit oriented, code transparent, and synchronous protocol. This protocol can be used in both wired and wireless communication. Now let's see CSMA CA protocol uh, and how it works. Uh, this acts as a station which can receive while transmitting data to detect a collision. The station receives one signal if there is no collision or its own signal. The station receives two signals if there's a collision, on signal and signal sent from the second station. These signals are identically different. Okay, now let's see what is MAC layer. MAC layer controls the hardware responsible for interaction with the wired, optical, or wireless transmission medium. Functions of the MAC layer are uh, it implements a trailer to detect transmission errors, control the NIC responsible for sending and receiving data on a physical medium, integrates various physical technologies, and also it provides a mechanism to allow multiple devices to communicate over a shared medium. Okay, now let's move to the next slide. Functions of LLC layer. As a LLC layer perform as an interface between the network layer and the MAC sublayer of the data link layer. The LLC sublayer is mainly used for its multiplexing property. This allows several protocols to operate simultaneously within a multi-point network over the same network medium. Now let's see frame format of LLC layer. Uh, this is the frame format of LLC layer, and now let's see frame structure of IEEE 802.3 MAC frame structure. As you can see, this is consist of 7 fields, and those are preamble, SFD, DA, SA, length or type of protocol data, unit PDU or upper layer data, and CRE. IEEE 802.11 architecture. Now let's see about this architecture. Uh, this architecture describes two services which are basic service set BSS and the extended service set ESS. This defines three types of stations based on their mobility in a wireless LAN. Those are node transition, BSS transition, and ESS transition mobility. Here in these images, you can see BSS and ESS architect, how those are architectured. Okay, now let's move to the next slide. And this is the final slide of my this video. IEEE 802.11 explains two MAC sublayers, namely the distributed coordination function DCF and point coordination function PCF. Frame control, which is a 2 byte starting field and it composed of 11 sub fields. The subfields are protocol version, type, subtype to DS, from DS, more fragments, retry, power management, more data, protected frame, and order. Duration also a 2 byte field, and there are 3 address fields which have 6 bytes. Sequence also 2 bytes field, while data carries the payload from the upper layers, and its maximum size is 2312 bytes. Frame check sequence or FCS uh, containing error detection data. It has 4 bits. Uh, Now I have explained all the things I have summarized in my first assignment of WNT module. Uh, Here, okay, in while doing this assignment, I have referred around 42 research articles, websites, and books. Here you can see the references list. If you wish to study further or for more reading, you can go through these references, and those are the references. And now I have come to the end of my video presentation, and thank you.